Alright, so in this video, I'm going to be solving the equation 2 to the power of x plus x is equal to 2. So, what I'm first going to start out by doing is subtracting x on both sides. So I get 2 to the power of x is equal to 2 minus x. Now, let's say I have something in the form a times e to the power of a. What I'm going to be using on this is the W-Lambert function. So basically what the W-Lambert function is, or what it states, is if I take the W of something in the form a times e to the power of a, this is just equal to a. So this is known as the W-Lambert function. So what we're going to be using for solving this equation is the W-Lambert function. So before we do that, I'm going to rewrite this a little bit. So I have 2 to the power of x is equal to 2 minus x. And I'm going to divide both sides by 2 to the power of x. So these two cancel out, and I get 1 is equal to 2 minus x over 2 to the power of x. Now, this is the same thing as 2 minus x times 1 over 2 to the power of x. And if I have something in the form 1 over a to the power of n, this is equal to a to the power of negative n. So I get 2 minus x times 2 to the power of negative x. Now, I'm going to multiply both sides by 2 squared. So I get 2 squared times 1 is equal to 2 minus x times 2 to the power of negative x times 2 squared. And now, if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So 2 to the power of negative x times 2 squared, those two add up. So I get 2 squared is equal to 2 minus x times negative x plus 2 is 2 minus x. Now 2 squared is simply equal to 4. So I get 4 is equal to 2 minus x times 2 to the power of 2 minus x. Now, from here, if I have something in the form e to the power of ln of a, this is simply equal to a, because the e and the ln cancel out. So this means that if I have something in the form e to the power of ln of 2, this is going to equal 2. So what I'm going to do is I'm going to substitute in e to the power of ln of 2 for 2 here. So I get 4 is equal to 2 minus x times e to the power of ln of 2 to the power of 2 minus x. And these two can multiply because, again, a to the power of m to the power of n is equal to a to the power of m times n. So now I get 4 is equal to 2 minus x times e to the power of 2 minus x times ln 2. Now, I'm going to multiply both sides by ln 2. So I get 4 times ln 2 is equal to 2 minus x times ln 2 times e to the power of 2 minus x times ln 2. And this is where we're going to bring in the W-Lambert function. So again, if I take the W of something in the form a times e to the power of a, this is equal to a. So, as you can see for our right-hand side here, this is in the form a times e to the power of a, because a is 2 minus x times ln 2. So I have a times e to the power of a. So now I'm going to take the w on both sides. So I have the w of 4 times ln 2 is equal to w of 2 minus x times ln2 times e to the power of 2 minus x times ln2. And this just turns into a. So I get w of 4 times ln2 is equal to 2 minus x times ln2. And if I distribute ln2 here, I get 2 times ln2 minus x times ln2 is equal to the w of 4 times ln2. Now from here, I can rewrite this as 2 times ln2 minus the w of 4 times ln2 is equal to x times ln2. And finally, I'm going to divide both sides by ln2. So these two cancel out, and I get x is equal to 2 times ln2 minus the w of 4 times ln2 all over ln2. Now, we aren't done yet, because we still have to simplify this. So, what I can actually do is plug this into a calculator such as Symbolab. So if I plug this into Symbolab here, and what you can also do is find the individual values of each of these. So you can find the individual value of 2 times ln2, subtract that from the value of w of 4 times ln2, and divide that by ln2. But I'm just going to make it easier by getting the exact value. So if I put this in Symbolab, I get that the value x is approximately 0.543. So this is going to be my solution, and you can even check this by plugging this into this equation here. You can do 2 to the power of 0.543 plus 0.543, but this is my solution.